In the previous video, we took a look at the approximate volume of this area with between these limits of integration. It was x is equal to 0 and x is equal to 3, but notice I could just grab the object here and change the limit of integration like this. So we'll set it out here as x equals 4, and then we had our little, this is our transparent cover. At least when I run the simulation, it'll be transparent to keep the objects in. But today we'll take a look at dynamic versus rigid body approximators and the stirring / shaking effect. Alright, and what this is that normally we were working with this cube and the pyramid and the tetrahedron like this, and let's say I'll use the pyramid. Let me start the simulation and I'll run the let's see if I can get that. Let me get a better view here like this. Alright, I'll run this now. Alright, so with the pyramid I had, let me put the pyramid in the scene, and notice the one thing, it rotates into the scene, right? Objects rotate. So what it is, I was using a rigid body, so rigid body physics in order to put these in. But in this case for the cube, I'll put the cube in the scene now. I'm taking the pyramid out, but now I've changed this to just dynamics. I've taken the rigid body rotation out of this one. So if I place it in here, where'd it go? I must have pushed too far. Oops, there it is. Alright, and there it's in, and you can see there's no rotation. Well, this actually may help us approximate certain volumes better because they lie flat right on top of each other. Well, that may or may not be good. I mean, if we're combining smaller objects with bigger objects and different shape objects as well, maybe the rotational aspects of a rigid body might be useful as far as helping to fill the volume. So let's take a look over here and just put the cube inside this volume area right here, and let me see, let me just move up like this. Let me see, we'll look down at a little more. Oh, and I forgot to put my let me do this. Let me just push this back into place real quick like that. Okay, and we'll rerun it. Okay, so there's my cube, and I'm going to change my view again. Alright, so get a close-up view, maybe like that. Alright, so I'll make sure he's being placed in there. Alright, so we'll place some in there. Well, so just even by placing that sparse amount, there is one thing I noticed, is that it's creating gaps, you know, in areas like this. Well, I need to deal with that somehow. And how do I get a cube up into that corner? Maybe I'm placing him in here where I could actually move it at different locations as I go, and like individually place it, but if I'm just generally filling in the volume. So what we can also do is we can stir and shake it up, and there'll be many methods of stirring and shaking, but this is just one where I'm going to try and push things up into the corner just like this, and then maybe by pushing those things up there a little bit like that, and maybe adding some more down here. Maybe I can squeeze some in, like, see that little spot is empty right there? Now I'm just doing some rotations here to try and see if I can get them to squeeze in there. But I know I can use a whole combinations of rotations and translations, and I'll have stirring objects in the whole 9 yards, and then maybe that'll help it, you know, squeeze them into those spaces like that. So there's a whole host of things to consider between the combination of the objects and shapes and the sizes and the whole 9 yards. I'm sure eventually we'll get it to the point where we can approximate a volume or an area reasonably well. Of course, if we had a really fast computer too, that helps. Okay, I'll see you in the next video.